Hi, and welcome to my basement. My name is Sassnowski. I'm here to talk to you about better testing in Laravel, and as always, I have a lot of slides to get through, so let's jump right in. Okay, before we get started, I want to give you a bit of context on why I test the way I do. What properties do I want from my tests? Because all the tips I'm going to show in the next 30 minutes or so will push my test towards one of these properties, one or more of these properties. So the first one is obviously to prove that the code works correctly, right? This is kind of a given, otherwise by definition it wouldn't even be a test. So this is just here for completeness' sake. The second one is the most interesting one for me. I want my test to allow me to refactor confidently. As I'm writing code for the first time, I'm usually pretty confident about whether or not this code works or not. And I can be wrong about this, of course, but most of the time I have all the context in my head, so I feel pretty good about does this code work or not. But if I or someone else come back to this code a few days or weeks or months later, when I no longer have that context in my head, then I want to be able to refactor this code and feel reasonably confident that I didn't break anything. Okay, so the main purpose for me isn't to show me that the code is working right now. It's to allow me to come back to it later when I no longer have all of that context and still make changes confidently. So the question is, how confident am I in my test suite? Because a test suite is not a guarantee that your code has no bugs, right? It only proves that the things you have thought of testing still work. So really, a test suite gives you a certain percentage of confidence, if you will. And the question is, what tests do I need to write that maximize that confidence? That if my test suite says everything's green, that I'm maximally confident in that actually being the case. And for me, that usually means writing more what some people will call integration style tests. So these larger tests that test more components at the same time, that make fewer assumptions, and as such, in my opinion, more accurately reflect how the code will actually behave in production. This is not really a unit testing versus integration testing talk, so I will just leave it at that. The next thing I think is very underappreciated about tests, and that is that they serve as executable documentation. So when I want to learn something about a new code base, I tend to look at their tests. Because in there, if the tests are well written, which is a fairly big if, I realize, but if they're well written, it'll outline all the weird edge cases this code has to handle, as well as what's the happy path. But not only that, I can actually run this documentation and see that what it's claiming is actually still correct. Because I think we've all had this happen, where there was this one comment in the code somewhere that claimed something about the code, and then hours later we found out, oh, that comment was actually outdated, and we just wasted a bunch of time looking for the error elsewhere. Right? So tests are actually executable, and so you can check if they're still up to date, which is really nice. And because I want them to serve as documentation, I want them to be as simple to understand as possible. Now, simple is obviously fairly subjective, and simple also usually means simple relative to the complexity of the thing you're testing, right? Some things are just inherently more complex, but within those constraints, I aim to make my tests as easy to read as possible so that they can serve as documentation. You may have noticed that fast is not on that list. Now, that doesn't mean that I don't care about fast tests. It just means I don't prioritize my tests being fast as highly as I do these other properties. So if I can make the same test faster, sure, I'll do it. But if it means I have to change the test in such a way that would make it less readable or would reduce my confidence in it because I have to mock more things and make more assumptions, I'm usually not willing to make that trade-off. I'll just put this out here because this is usually one of the biggest points of criticism about this more integration style testing, is that your tests tend to become slower, which is true, but I'm just saying I am aware I am making a trade-off, but that trade-off for me is worth it. Okay, now let's get started with the first code-related tip. And this is about reducing unnecessary details in tests. I've actually blogged about this, so if you've read the blog post, this will be very familiar. And this is a fairly large topic, and I'm just going to show one example of what that might mean, or what that might look like, because I don't think a lot of people think about this as a problem. And so I want to show you an example of what unnecessary details can mean and how you can get rid of them. So let's say we have a test like this. We're testing a CRUD endpoint. Okay, so we have this game resource in our app. Doesn't really matter what a game is, it's just a resource. And then we have the endpoint to create a new game, and this is what we're testing here. So let's step through this test. First of all, we create a user because only an authenticated user can create a game. And then as that user, we will post to that endpoint and pass along the required payload. And I want you to pay special attention to the name and the description here. We'll come back to them in a second. Just realize that they will be the stars of the show. And then at the very end, to see that everything worked, we will take a look into the database, the games table, and check that there's a record here that belongs to this user and has the same properties that we passed along in the request above. And again, there's name and description here. Just keep them in mind. So that's test number 1. Let's go to test number 2. So this is about a serial number value object, if you want. So you have some class in your application that represents a serial number because you don't want to deal with strings all over the place. And so a serial number can be constructed from a string, and this is what we're testing here. So the first case is we're trying to construct a serial number from a valid serial number string. Okay, so we try and instantiate the serial number with its static from string constructor, and we pass along this ABCDEFG string, which apparently is an example of a valid serial number. And then to check that everything works, we will just stringify the serial number object and see that we get the same string back as we put in at the beginning. All right, that's test number 1. And then the second one, where we want to check the error case, what happens if we try to instantiate this object from an invalid serial number. Well, in that case, we will expect an invalid argument exception to be thrown. And then when we try to instantiate a serial number object with this 99999 string. And so 9999 is apparently an example of an invalid serial number. Okay, so these are our 2 different tests. Now, they're obviously very different, right? The first test was a very high level. We're testing an entire route. We're hitting this endpoint and we're looking to the database. This is pretty much as big as it's going to get, right? Because whatever needs to happen in between actually needs to happen. Whereas this one, the serial number test, is more of a straight up unit test. We're only concerned with the serial number object and only one of its methods. And that method really doesn't have any collaborators. It just takes in a string and then either throws an exception or doesn't. So why should we even compare these 2 tests? So what's up with these strings that I've been pointing out, this name and the description and even the serial number string? Why are they relevant here? So if you look back at the first test, let me ask you a question. Is it important that the name of this game we're creating in our test is My Super Cool Game? And is it important that the description of this game is a really long description that no one will ever read? Or could we do something like this, for example? Just use the name of the game as its description. Just use the same string for both of them. Would that still work? Sure, right? As long as we remember to also update the assertion to check against this changed string, this test would still behave the exact same way. So could we do this? Just use a garbage string, right? Just 5 A's in both cases. And sure, that would work again as long as we update this assertion. Because what this means is, in this test case, we're only interested that these 2 strings matched, that the string we pass along to the request payload matches what ends up in the database. So we only care about what these strings represent, right? So one represents the name of the game, one represents the description of the game, but we don't care about their exact values. We could have picked literally any string for either of those 2 fields, and as long as what we pass along to the request and what ends up in the database matches, that would satisfy this test. Okay, so the string value does not matter. What about this case? What about the serial number? Can we do the same thing here? So if you look at the second test where we say from string 99999, can we do this? Can we use the same serial number as in test number 1? Well, no, right? If you think about it, this test explicitly expects an exception to be thrown because this test deals with an invalid serial number. So these two tests cannot pass at the same time with the same input string, because that would mean that same string represents both a valid and an invalid serial number, which obviously isn't possible. So in this case, the value of the string actually matters. The first string, it's important that it is A, B, C, D, E, F, G, and the second string is important that it's 99999. We can't just arbitrarily pick any string. Now, there might be multiple examples of what a valid serial number string might look like, or what an invalid serial number string might look like, but we can't just pick any value. So in this case, the value of the string actually matters. Now, why is this important? This might seem like hair splitting, but the thing is that, think about the first test again. If I, someone who is not familiar with this code base, read this test, the first test where we test the game creation, I have to assume that everything in this test is relevant somehow. So I can't just assume that the name and the description really don't matter. They need to be provided, but who cares what their value is? Because how am I to know that you're not, for example, disallowing certain words in the title of the game? Right? So I have to assume that they're relevant somehow, even though they're not. So we should make obvious what's relevant and what isn't, so that someone who reads a test knows which pieces of information they can ignore and lower this cognitive overhead, like the mental overhead of a test, as much as we can. So I want to communicate this information to a reader to say, hey, by the way, this string, don't worry too much about it. It's just the name of the game. It doesn't matter. And in the other case, to signal, hey, pay attention to this string specifically because it is actually important. And the way I do this is like this. Now, this test barely hasn't changed. Whoops. Except that I've replaced the name and the description, the string values, with these weird double colon strings. So colon, colon, name, colon, colon. What this means is this is a string that represents a description in that case, but its actual value doesn't matter. And the same goes for name. This is a string that represents a name, but its actual value doesn't matter. So whenever I see in a test this colon colon syntax, I know, okay, I don't have to care about the value of the string. It's just a placeholder basically for name or description. That also means if I don't see that, like in the serial number test, that signals to me, okay, I better pay attention here because the specific value of that string that was chosen here is actually important. Now there's two obvious. One is it only works for strings, right? You can't do the same thing with numbers. And it might not even work for all strings in all cases, because in the case of an email, for example, you might have a validation rule later on that checks that this string is actually a valid email. So if you just do colon colon email, that will actually not pass this validation rule. But this works for the 80% use case. So I've introduced this concept to 3 or 4 different development teams, and they all ended up using it because it is a very simple change to make. It's really just a naming convention, but it is surprisingly powerful in what it communicates about this test. So even though this might seem weird to you right now, I encourage you to at least try it out and see if it improves your tests. Okay, let's move on to something more specific, testing validation. So let's say we have a controller like this. And in this controller, this is basically an endpoint to create a user, okay? And in here, we will first validate the request payload, that all the required fields have been provided and that they have correct values. So how can we test this? Let's start with name is required. If we were to just write one test that checks that the name is actually required for this endpoint, here's how that might look like. So we just send a post request to this endpoint, and in the payload, we explicitly leave out the name field, right? We just don't pass it along. And then we assert that the session has an error for this field, so the validation rule should have triggered. Now this test is pretty straightforward and it works. The problem is that we have a lot more validation rules than just name is required. So it would really look something like this. And all of those tests would look very, very similar. And when things look similar and you have to do the same thing over and over again, it becomes tedious to write. And when things become tedious to write, people stop writing them. Okay, so this is a bit annoying, but I still want to have all of these tests, right? I still want to validate that the EMA is required and that it must be valid and that it must be unique. I just don't want to have to write 6 or 7 tests for every endpoint. So what I do in this case is I utilize data providers. With a data provider, we can do something like this. So let's change up our initial test. And so instead of having name is required, we'll just have a generic validation test. And then we annotate that test with this add data provider property. And we point it to some method that we haven't defined yet, this validation provider method. And then we need to parameterize this test. So it now takes 2 parameters. It takes the payload that we're going to send, and then the name of the field that is supposed to have the error. That's a key parameter here. And then inside this test, what we do is, it's basically the same test as before, but we just replace these hard-coded values of the payload and the field name with the variables, right? So we pass along payload and the key. And so inside our validation provider, here's what we're going to do. First of all, I tend to return generator expressions from my validation providers. Don't worry too much about this. You can just use arrays. And this is the interesting bit. I usually define a default payload inside my data provider. And this payload represents a valid payload. So if I were to send this payload along to the endpoint, everything would pass. And then down here, where I will actually return the individual test cases, the first one being missing name, I need to provide these 2 parameters that our test needs. I need to provide the payload and the name. And what I do inside payload is I use Laravel's array except helper, which basically takes an array and a key in that array, and it'll return the array without that key. So we can now utilize this default payload and just remove the name. I do this because I only want one of those fields to fail, right? So I take the valid payload and only remove the name, and that gives me the payload that I want, which is everything is correct except the name is missing. And then of course I have to say, and in this case with this payload, the name field is supposed to have the error. Right? So this is our validation provider with a single test case, the missing name. And if you run this, this actually works. And also notice that it says with dataset missing name. That's kind of nice because in here where it says yield from in the next line, we set missing name as the key. If we don't provide that, it would just say with dataset 0, with dataset 1, 2, 3, 4, and so on. And it's kind of annoying if dataset 4 fails and you have no idea what that is, and so you have to go back to your data provider and start counting. So this is kind of nice because it shows up in the output. Okay, you might say, missing fields are easy. What about incorrect values, right? So let's say we want to test this password has to be confirmed rule. So in this case, we're concerned with these 2 fields, password and password confirmation. And basically what we want to do is we want to pass along a payload that looks like this, right? As long as the password and the password confirmation field don't match, this validation rule should trigger. And again, notice I'm using this double colon syntax to say, this is just a password, but it doesn't matter what exactly the password is as long as they don't match. So how can we do this? Well, we can make use of array merge. So what we can do is we can take this default payload and merge it with another array that also specifies the password confirmation field but this array has the incorrect value that we want to use. And if you merge those two arrays together, we get this resulting array, which is exactly what we want. So in our data provider, let's define a new test case where the password is not confirmed. And in here, where I specify the payload, again, I will use this default payload because I only want the password confirmation field to be incorrect. And so I merge the default payload with this other array that specifies the incorrect confirmation value. And then, of course, I say the password field is the one that should be wrong in that case. And if you run this and also do this for all the other test cases, this will work for almost all of them. Except, what about unique emails? We kind of skipped over that one, but that's kind of the most important one. Or not the most important one, but the most interesting one. Because if we think about how would we write a single test to check that the email is unique validation rule gets applied correctly, it might look something like this. It looks very, very similar, except that at the very beginning, we explicitly create a user with an email, and then we use that exact email in the request payload, and that should cause our validation rule to trigger. So really, the only thing that's different here is this user factory create line. And what that is, it's just a setup step, right? We need a way to provide a setup step. One way we can do this is we can extend our validation test to accept an optional third parameter, which is a setup, which is just a function that we can call. And if it is provided, then we will call it, otherwise we don't. And then this function can do whatever it needs to. And the rest of the test stays the same. So here's how we use this in our validation provider. So down here, we define this email already exists test case. Payload and key stay the same, right? The payload is actually correct. The only thing that's wrong is down here in the setup step. And in here, we will do that same step that we just had in our single test case, where we create a user with the email that we're about to use. So with the email that comes from the default payload. And with that, we can now cover all of these test cases. Now, the setup step thing might be something that might be taking it a bit too far for you, right? Where you feel like this is making it pretty hard to read, and it's pretty it's a weird special case somehow. That's fine. You don't have to use it. I just wanted to show you that something like that is possible, and data providers are actually really powerful and useful. And I used them a lot for validation tests like this. Okay, so this is the last big chunk of this talk, and it's also the most interesting one for me. It has the most things to talk about. It's about testing middleware, so HTTP middleware. And to go through this example, let's say we have this very simple admin middleware. So all it does is it looks at if we have a currently logged in user, so that's this request user thing, and then it checks if that user is an admin. And if not, we will abort. Otherwise, we just pass the request along to the next middleware. So fairly straightforward. I actually use this exact middleware in quite a few of my projects because oftentimes this is the only sort of permission handling that I need. You're either an admin or you aren't. So this is actually the real deal. Now the question is, when you test middleware, why not just use a real route, says my hypothetical listener that I've called Bob. So sure, Bob, here's the problem with using a real route. Let's say our routes file looks like this, okay? So we have some routes, and then there's this one route that I've called admin.users.store that uses this admin middleware. So why not just write a test like this, where we essentially test the middleware indirectly by testing this specific endpoint? So why not just create a user that is explicitly not an admin, and then try and hit that endpoint as that non-admin user, right? In this case, the payload doesn't really matter. And then we assert that the response is a forbidden code because the middleware should have returned a 403. So this works. This would actually work correctly and does what you think it does. But think about what we're actually testing here. Look at this test. This doesn't test the middleware. It's testing this create user endpoint. And the middleware is kind of a weird implementation detail that isn't really mentioned anywhere. This test might be fine if this admin user store route is the only route in your application that uses this admin middleware. Even though at that point I would kind of question why you even have a middleware to begin with, right? But if this was the only place where this middleware is actually used, this might be an okay test. However, what instead of like this, your routes file looks like this. Now you have this route group and all of those routes now use this admin middleware. So now we have 1, 2, 3, 4, 5, 6 routes that we would have to test to see if they all require an admin. What if it looks like this? What if it looks like this? Right? Okay, so I'm just copy pasting the same 6 routes over and over again, but you get my point. Usually when you have a middleware, it's because you have quite a few routes that are supposed to use this middleware. So this leaves us in a bit of a pickle. Because should we either include that same test that we just wrote for this single endpoint for every single one of those routes? If yes, what if the middleware needs to change? And again, that is a lot of duplication, right? This is the same test over and over again. So what if we don't do that, if we don't want to write the same test for every single route, can we just use one of those routes as sort of a proof of concept and we prove that the middleware works and then we kind of assume that we correctly put the other routes in that same middleware group? That already feels kind of weird. And even if we did, well, which route do we choose and why this one? And again, what does this communicate to someone who is unfamiliar with your code base and reads this test? Why does this route have this one weird test about it needing an admin user and the other ones don't? Is this route somehow special? Do the other ones not, can they be used by even non-admin users? And then you go check the routes file and you see, well, no, they're in the same route group. This is really weird, right? It's confusing. So here's what I want to do. I want to test the middleware at the HTTP level. So I want to actually send a request. Again, this is a fairly large test, but they give me the most amount of confidence. But at the same time, I don't want to use an actual application route because it's confusing. The solution to this is actually pretty simple. There's nothing stopping you from, in your test, to just define a route. So in this admin middleware test, we can define a setup method, and in here, we just define a route. And we make sure that this route uses our admin middleware, and then we can use this route for testing the admin middleware itself. And it's very clear that this route is not special because it only exists during the life cycle of this test. So there's no confusion here. But now we can test the middleware like this, where we can say, well, if I have an admin and I post against a route that is protected by this middleware, everything should be fine. If I don't have an admin, so if I have a non-admin user and I try and access a route protected by this middleware, then there should be a forbidden. Technically, there's a third test case here missing. What if we have only a guest user, right? We don't even have a user. That should also be forbidden. But this is now really nice to test. And we don't introduce this bit of confusion about why are we using this route? So now that we know that the middleware works, the middleware independently from any application-specific routes, we can really just check if the route uses the middleware. You don't have to repeat the same test over and over again. And to do that, I will point you to a package query called Laravel test assertions. One of the assertions that it provides is assert route uses middleware, which does exactly what it says on the package label. So you just provide it with this route, this middleware, please tell me if it's using it. So to test that the admin user's store route uses the admin middleware, we can just say this assert route uses middleware, this route, this middleware. And then that's enough because we have tested the middleware separately and we know that it works, so we don't have to repeat that same test over and over again. And if we want to do this for multiple routes, we can again make use of data providers. So we have a data provider that provides us with a whole bunch of route names. All of these routes should be protected by this admin middleware, and then we just parameterize this test, and instead of hard coding the user's store route, we just use the parameter. One additional nice thing that we can now do is in our tests, we can deactivate this admin middleware. There's this built-in function in Laravel test cases where you can say this without middleware and then provide it the middleware class that you want to deactivate during this test. So why would I want to do that? Why even deactivate the middleware? Let's look at a different middleware. This is an actual middleware that I've lifted from one of my real projects. Don't worry too much about the specifics, but so the first thing that's weird here is we're interested in not the request user, so not the currently logged in user, but the request route user. So the user we care about is specified as part of the URL. And then we want to check that user if they're not still on their trial, or if they don't have a valid subscription, then that route doesn't exist, right? And if it does, everything's fine. So to test this middleware, here's what I do. And look at that beautiful test name. So I create a user, and then I explicitly create a subscription for that user that is still valid, right? It says ends at null. And then I will call this route. I don't know why it says user get. So we get the user route key here. And since that user has a valid subscription, everything should be fine. Now think about what I would have to do if I was using this middleware in my tests. I would have to, even though I have tested the middleware and I have tested that the route uses the middleware, I would still have to do all this crap for every single route just to get through the middleware, right? I want to test the route itself, but I still need to satisfy the middleware. So I need to do all this stuff even though I know the route is using the middleware and I have tested the middleware. And so again, that would just detract from the thing we're actually testing, which is the route, not the middleware. It doesn't add any additional coverage because we have covered the middleware with its own test case, and we know that the route is using the middleware. So this doesn't really provide us any additional confidence. So in this case, I would like to disable the middleware so that we can, again, reduce this mental overhead of, as I'm reading the test, I'm removing unnecessary details because the middleware doesn't really matter here. So in these cases, it can be useful to deactivate the middleware. So to sum up, to test middleware, we create a separate middleware test. We define a dummy route within that test setup method, and then we can test that middleware with that dummy route. Then in our route test, we just check that the middleware is actually being used by this route. And then depending on how much setup this middleware would require, we can deactivate it in our actual route tests. So that's all I have for you today. I hope this was useful. I hope there were some things that you were able to take away from this talk. And even if you disagree with some of the tips that I have shown, that you at least now know what my thinking behind them was, and maybe you can come up with your own ways of testing using those same questions that I asked about what is it that you actually want to get from your tests and what properties do you value in your test suite. So I'm Sassnowski. Thank you very much for listening. Enjoy the rest of the conference. See you around. Bye.